Hello, welcome back to Learn Physics. In today's topic, we are continuing with the electrostatic potential and capacitance. So here in last class we learned till about the equipotential surface and a relation between E and V. E is equal to minus dV by dl. Till there we learned, right? So and I gave you some numericals, that is homework questions. So I think you would have done that. So we'll check it now. The first one was the electric field intensity at a point B due to a point charge Q kept at a point A is 24 Newton per Coulomb, and electric potential at B due to same charges 12 Joule per Coulomb. Calculate the distance between A and B. So electric field intensity at the point A is given as 24 Newton per Coulomb. So electric field E equals 24 Newton per Coulomb. Okay, this is kept at A. Now electric potential at B due to the same charge is 12 Joule per Coulomb. So electric field, the potential is given as 12 Joule per Coulomb. Okay, so B also at the same distance. We should find out the distance AB and magnitude of charge. So electric field at a point B due to a charge Q which is kept at A. So this is electric field at the point B and this is the potential at the point B. Okay, so we should find out the distance between A and B. How we can do? So a Q is kept at A and it is electric field at the B is given and electric potential at B is also given. We should find out AB distance. How we can find out? E equals 1 by 4 pi epsilon 0 Q by R square and potential equals 1 by 4 pi epsilon 0 Q by R. Okay, so what is this R square? R square is the distance. See here, due to this Q, what is the electric field at the point B? So R will be this distance. So here we need to find out this R value. How we can find out? We can divide V and E. V by E equals 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 will get cancelled. Q by R divided by Q by R square. Q also will get cancelled. So we will get it as, see, 1 by R into, take the reciprocal and multiply, will be equal to R. So V equals 12 Joule per Coulomb, that is equal to E into 24 into R. Therefore, R will get it as 12 by 24, that is equal to 0.5 meter. And here it is charge also asked, right? So R is given, so we can find out the charge by substituting in any one of these equations. So while I am substituting for V value is 12, that is 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. Q value we need to find out. R is already, we got it as 0.5. So this will be equal to 6 equals 12 into 0.5 is 6. So here equals 9 into 10 to the power 9 into Q. Therefore Q equals 6 by 9. 6 by 9 means we can write it as 2 by 3 into 10 to the power minus 9 Newton per Coulomb. Charge unit is Coulomb. Clear? Next question is, two charges 5 into 10 to the power minus 8 Coulomb and minus 3 into 10 to the power minus 8 Coulomb are located 16 centimeter apart. So those two charges are at a distance 16 centimeter. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So here, like the same kind of question we did for electric field also, force also we did it, right? At which point the electric field will become equal to 0? That questions we did. Okay, same way only. Here Q1, Q2, that those two charges are given by the values. Q1 equals, okay, Q1 equals and Q2 equals, and distance between Q1 is given as 5 into 10 to the power minus 8. 5 into 10 to the power minus 8 Coulomb. Q2 equals minus 3 into 10 to the power minus 8 Coulomb. Okay, then it is separated by the distance. 16 centimeter. We should know at electric potential is 0 at which point. So potential, what is the formula? 1 by 4 pi epsilon 0 Q by R. Okay, so we should find out the net potential should be equal to 0, that is V1 plus V2 equals 0. Like that we should find out. So if we are drawing the diagram, this is Q1 and this is Q2. This is 16 centimeter. At one point P, at a distance x from Q1, I am considering potential will be equal to 0. Okay, how we can find out the net potential? V1 plus V2. For that we need V1 and V2. What is V1? 1 by 4 pi epsilon 0 Q1 divided by, what is this distance? Distance is x. Okay, so this is x and x. Next, what is V2? 1 by 4 pi epsilon 0 Q2 divided by, what is this distance at the point P? 16 minus x. Okay, this is 16 minus x. 16 minus x. That is V2. Now at the point P, that is potential will be equal to 0. That is equal to V1 plus V2. What is V1? V1 is 1 by 4 pi epsilon 0 is common in both the cases. So Q1, what is Q1? 5 into 10 to the power minus 8. 5 into 10 to the power minus 8 divided by x plus, what is V2? Minus 3 into 10 to the power minus 8 divided by 16 minus x. Okay, solving this one we will get it as 9 into, this is equal to 0. Right, so 9 into 10 to the power 9. This is not equal to 0. Right, so we can consider that 5 into 10 to the power minus 8. 10 to the power minus 8 also common. So that also we can take out 5x minus 3 by 16x. Okay, so here while taking the solving this one, 5 by x equals 3 by 16 minus x. So here we will get it as cross multiplying. We will get 80 minus 5x equals 3x. So 80 equals 8x, x equals 10 centimeter. Okay. Clear, right? So this kind of questions now you understood, I guess, because net potential is equal to 0. At which point? It is easy. You can easily find out. Next is, a point charge Q is placed at point O as shown in figure. Is the potential difference VA minus VB is positive, negative or 0 if Q is positive and or second one Q is negative. So here the charges are given as, this is O, this is A and this is B. Q is the charge which is kept at the point A, at the point O. Okay, is the potential difference VA minus VB? VA minus VB, whether it will be positive or negative or 0. We should find out. This is the question. In which case we should consider if Q is positive and second one is if Q is negative. Okay, we should find out the VA minus VB value, whether it is positive or negative, if Q is positive and Q is negative. So VA minus VB, how we can find out this one? VA minus VB. For that, first we can find out one VA. VA is 1 by 4 pi epsilon 0 Q by this distance. Right. So 1 by 4 pi epsilon 0 Q by distance is OA. And VB is 1 by 4 pi epsilon 0 Q divided by OB. Right. So here Q by 4 pi epsilon 0 is common here in VA and VB. So instead of that we can write it as K by OA and this one I am writing it as K divided by OB. Now we are going to find out VA minus VB. VA minus VB will be equal to K into 1 by OA minus 1 by OB. So here this Q also I am considering here KQ, because Q is positive, Q is negative, right? So Q by OA, Q by OB. So when this value, if Q is positive, first question, if Q is a positive value. Okay, we know OA is less than OB. Okay, so this will be a positive value and this will be a negative, a smaller value. Okay, this is OA less than OB. Therefore, 1 by OA will be greater than 1 by OB. So which will be greater? This will be greater value minus smaller value. So this will be, Q will be positive. If Q is positive, VA minus VB will be a positive value. And second one, if Q is negative. If Q is negative, here we are getting a negative value. Right? Here is negative. So here what will happen? 1 by OA is a greater value, that is negative. Greater value is negative means VA minus VB will be a negative value. Understood how we are finding out this one? So Q is positive means here we will be getting it as 1 by OA minus 1 by OB, that is greater value minus a smaller value. Greater value will minus smaller value will be a positive quantity. If Q is negative, what will happen? This will become minus and this will become plus. So here smaller value is positive and larger value is negative. So while taking the subtraction, we will get a negative value. Clear? So how we are finding out? So next is potential energy of a system of charges. System of charges. So many charges are there. What will be the potential energy? How we can find out the potential energy of the system? Potential energy will be equal to the work done. Right? So energy is equal to the work done. So W divided by Q. V equals W by Q. That one we already learned. Right? Infinity to A, that is equal to divided by Q, that is equal to potential. So if we want to find out the work done, how we can find out? Q into V. Okay, here I am considering potential energy of a system of charges. So this one you keep it in mind. First I am bringing a charge Q1 where there is no charge at all. So no need to do any work, extra work is not necessary. So here for a particular point P, which is at a distance R from Q1, so the potential will be V is equal to 1 by 4 pi epsilon 0 Q1 divided by R1 P. I am considering at point P. At P, potential will be 1 by 4 pi epsilon 0 Q1 by R1 P. Okay, now I am bringing another charge Q2 to the situation. Okay, now this potential is present over there. Now I am bringing another charge Q2. So for that I should do work. So if I am bringing, another charge Q2 is coming into is bringing. Okay, if we are bringing another charge Q2 to the situation, how this work done will be there? Right, here initially there was no other field was there, therefore work done will be equal to 0. Here in presence of Q1, I am bringing another charge Q2. So I should do some work to against this Q1. Right, how we can find out this work done? Work done will be equal to Q into V. How much of charge I am bringing? Q2 charge I am bringing. Already V at P we have. Right. So what is V? Q2 into 1 by 4 pi epsilon 0 Q1 by R1 P. Okay. So I can write it as 1 by 4 pi epsilon 0 Q1 Q2 divided by R1 P. Okay, clear? So this work done will be converting as potential energy. It is depending only on the initial and final charges. Okay, so here this work done, that is converted to potential energy. Therefore, potential energy of a system of charges is equal to 2 charges at present means it will be equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R1 P. Now, if I am bringing a third charge, what will happen? See, I should do work against the first charge and against the second charge, right? So, how we can do? So, if three charges are present, so three charges. In these three charges, already Q1 is present and Q2 is present. Due to Q1, a potential is there. V is equal to 1 by 4 pi epsilon 0 Q1 divided by R1P. And due to Q2, another potential will be there. That is 1 by 4 pi epsilon 0 Q2 divided by R2P. Right, so we should do the third charge should work against Q1 as well as Q2. So what will be the total work done? Total work done will be equal to Q3 into V1 plus Q2 into V2. So we will get it as 1 by 4 pi epsilon 0 Q1 Q3 divided by R1P plus 1 by 4 pi epsilon 0 Q2 Q3 divided by R2P. So this is the work done in bringing the charge Q3 to these two charges. So already between Q1 and Q2 some work should be done, right? So that also the total work done will be equal to initially between Q1 and Q2 how much of potential energy work we should do 1 by 4 pi epsilon 0 Q1 Q2 divided by R1P plus, and along with that we should add this also 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 plus 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Okay, so that depending on which and all it is coming into effect. So this is the final work done if we are considering a system of charges, three charges, that is between 1 and 2, 1 and 3, and this is 2 and 3. Okay, R2, 3 already we should. So here it's simple. Potential energy between 1 and 2 means Q1 Q2 divided by R12. 1 2 3 means 1 2 1 3 and 2 3. Okay, total potential energy. So the concept you should know, initially no charge. Then second one coming, so at that time work should be done. Third one coming means first one and second one should do work against the first one and second one, and first one and third one, second one and third one. So three charges will be there. So everything we should. So suppose if fourth charge is there, means you tell along with me 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4. This much of work will be done. Okay, clear? So 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 will be equal to the potential energy of two charge between the two charges. So 1 by 4 pi epsilon 0 Q1 Q2 by R square is Coulomb's law. 1 by 4 pi epsilon 0 Q by R is potential. Okay, so all these things you should learn clearly, and electric field in between we learned 1 by 4 pi epsilon 0 Q by R square. Okay, so all these things you should study that nicely. Next we are going to study about the potential energy of a system of charges and a single charge in a uniform external electric field. So in presence of an external electric field, if I am bringing a charge, what will be the potential energy? So potential energy in presence of an external field, Okay, so and suppose an external electric field is present over there, what will be the potential energy to bring a charge to this external field? Due to external field, there will be at a distance r from a particular origin, at a distance r, a potential will be there, right? So due to external field at point r, at a point P, which is at distance r from origin, then potential is V of r. I am considering it as V of r. In that distance, that is at this distance r, I am bringing a charge q. Then what will be the work done in that? Work done will be equal to q into v of r, qv. Right, this will be the work done. Okay, this work done will be stored as potential energy. Okay, now instead of this a single charge, if a system of charges are there, suppose a q2 charge is coming. Okay, so q1, q2, like that if I am considering, first I am considering a single charge q1. So work done will be equal to q1 into v of r1. Okay, now I am bringing another charge q2. Okay, so what will be the work done due to that? Work done will be equal to q2 into v of r2. Okay, now already one q1 charge is there and another charge q2 is coming, right? So this is due to uniform external field. Okay, apart from that, we should do work against q1 and q2. What will be the work against q1 and q2? That is work done against q and q2 is, I am writing it as w3. So that will be equal to 1 by 4 pi epsilon 0 q1 q2 divided by r12. Okay, so what will be the total work done? This is the work done due to the external field. This is the work done due to external field. This is the work done due to these two charges which is present now. Okay, at the point r. So here that is equal to total work done will be equal to q1 into v of r1 plus q2 into v of r2 plus 1 by 4 pi epsilon 0 q1 q2 divided by r12. Clear? This is how we will be finding out the potential energy in presence of an external electric field. Okay, so this is an important topic only, this potential energy, 1 by 4 pi epsilon 0 q1 q2 divided by the distance between those two charges. Okay, that one you should understand clearly. So now we don't have time to complete our say at least 2 numericals we should do, then only some things will be there in your mind, right? So anyway, I'm not giving any numerical today. And by heart the formula, understand the concept clearly. After that, tomorrow we will do some numericals relating to this. Okay, so as a check your concept, I am giving some previous year question paper relating to the previous portions which I did. Okay, so go through that thoroughly and find out your answers and keep, and tomorrow we will discuss about that. Okay, so I think it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.